Hello students. So we'll continue our discussion on aldehydes and ketones. In the last session, we had discussed a few three reactions and their mechanism. We are going to discuss in this session another two or three reactions. The first reaction that we are going to discuss is Clason, okay, Clason Schmidt reaction. Okay, so this is nothing but a cross aldol condensation. So in the last session we had discussed about the aldol condensation where aldehydes or ketones having alpha hydrogen, they undergo self condensation. Okay, self condensation to give you aldols, okay, which undergoes dehydration later to give you alpha beta unsaturated systems. That is the other thing. So molecules containing alpha hydrogen in presence of a base, they undergo aldol condensation. When an aromatic aldehyde or a ketone reacts with aliphatic aldehydes, ketones or esters having alpha hydrogen. See, whenever aldehyde or a ketone, aromatic aldehyde or a ketone reacts with aliphatic aldehyde, ketones or esters having alpha hydrogen under basic condition, a cross aldol condensation product is obtained, okay, which undergoes dehydration to form alpha beta unsaturated aldehyde, ketones or esters. This reaction is called Clason Schmidt reaction. Okay, this reaction is called Clason Schmidt reaction. Let us take an example of this reaction and let us analyze this. I mean, let us go in detail about this reaction. What is this Clason Schmidt reaction? Now, let's take an aromatic aldehyde, that is C6H5 CHO. Okay, C6H5 CHO. Okay, this is an aromatic aldehyde. When this is treated with an aliphatic aldehyde, ketone or an ester having alpha hydrogen in presence of a base, okay, that is 10% NaOH is enough at low temperatures, okay, at room temperature, they undergo a simple cross aldol condensation. That means NaOH abstracts a proton from this, okay, this anion generated will attack this carbonyl carbon, so resulting in the formation of this compound, that is C6H5 CH double bond CH CHO. So you get alpha beta unsaturated aldehyde here. This is cinnamaldehyde. Okay, if you take a ketone, you get a ketone here. If you take an ester, you get an ester here. So this reaction is referred as the Clason Schmidt reaction. So take the same molecule, I mean take an aromatic aldehyde C6H5CHO, treat it with a ketone. Under same condition, that is 10% NaOH. NaOH abstracts a proton from this, whatever the anion generated attacks this carbon. So you get C6H5 CH double bond CH, C double bond O CH3 is what you get. right? You get a ketone there. Okay, so this reaction is referred as the Claisen-Schmidt reaction. Let us go for the mechanism of this reaction. Let us see the mechanism of this reaction. What is actually this reaction is what we are going to discuss now. Right now. So the reaction occurs in several steps. So we are going to discuss in detail the mechanism of this reaction. Step 1. So what actually happens in step 1? So in step 1, whatever the aliphatic aldehyde containing alpha hydrogen that you have taken, you can take an aldehyde, ketone or an ester, whatever you have taken, but it should contain an alpha hydrogen. So the base that you have used, it abstracts this proton. Whatever the proton that is there, it will abstract that proton. Now, getting my point. So resulting in the formation of CH2 minus C double bond O, H is what you get, plus H2O. So in step 1, the base abstracts this proton and it generates an anion. Okay, now whatever the anion that is generated here, it attacks the carbonyl carbon here. It attacks the carbonyl carbon of this aromatic aldehyde. So it attacks double bond O, it's converted to single bond O minus, that is C6H5 O minus, you have H, CH2, C double bond O, H. Okay, this is what happens. This anion, oxonium ion is what we can call it as, takes up a proton from an solvent to form an aldol. This is simple condensation that we have discussed in our last session itself. So this ion, that is C6H5C O minus H, CH2 C double bond OH, takes up a proton, C6H5C OH, CH2 C double bond O H. Okay, now next what happens is there is loss of water taking place here, that is OH and H from here. So dehydration takes place. I will write that step also. C6H5 CHOH, we have CHH C double bond OH. Okay, whatever the base that you have used takes up this proton. Okay, whatever the base that you have used takes up this proton. So the electron, they move here and this goes off, right? So there will be loss of water taking place, minus water to give you C6H5. There will be loss of water taking place to give you C6H5 CH double bond CH C double bond OH. This is what generally happens. So the reaction takes place in 4 steps. As usual, the alpha hydrogen is abstracted, resulting in the formation of anion. The anion generated attacks the carbonyl carbon. This takes up a proton, then loss of water takes place. Okay, this is nothing but a cross aldol condensation. Okay, This condensation of this aliphatic aldehyde ketones or an esters having alpha hydrogen with aromatic aldehydes or ketones is called as Claisen-Schmidt condensation. Okay, so this is the Claisen-Schmidt condensation and a very important condensation this is. Now let's go for the another reaction. Then another reaction that we are going to discuss is the Perkins reaction. Perkins reaction. Now, so this is a reaction between aromatic aldehyde which do not contain alpha hydrogen and the anhydride of an aliphatic acid containing alpha hydrogen. The reaction takes place in presence of a weak base like sodium or potassium salt of the same acid. Okay, whatever the anhydride acid that you have, whatever the anhydride you have prepared by using an acid, the same acid salt is what you should take. Let's take an example. So we should take, this is the reaction between aldehydes which do not contain an alpha hydrogen. So the benzaldehyde, aromatic aldehyde which do not contain alpha hydrogen with anhydride. Let us go for the acetic anhydride. Okay, let us go for the acetic anhydride, that is CH3, C double bond O, O, C double bond O, CH3 in presence of sodium acetate. Okay, condensation takes place. Okay, resulting in the formation of alpha beta unsaturated carboxylic acids. Okay, let us go for the mechanisms also. So what happens is here. So generally it is a weak base, but it abstracts a proton from here. This attacks this. So it results in the formation of C6H5 CH double bond CH C double bond O OH. Okay, you get cinnamic acid. Plus the remaining part, that is CH3COH. You get acetic acid. So this reaction is referred as Perkins reaction. So this reaction occurs in 5 steps. Let us go in detail about these 5 steps that the reaction takes place. Right, yeah. It's a very important reaction this is. Now, step 1. We are going to deal with the mechanism. As usual, this is a base. So obviously it will abstract the acidic proton. So we have an acidic proton here. So this base, that is CH3CO minus, okay, will abstract a proton. This proton, I will write it like this. C double bond O, O, C double bond O, CH3. So this will take up this proton. It results in the formation of this anion. You get CH2 minus, C double bond O, O, C double bond O, CH3 plus CH3COOH. Okay, and negative ion or carb anion is generated. Now, so whatever the carb anion generated will attack the carbonyl carbon of the benzaldehyde. Right, now we have C6H5 C double bond OH, CH2 minus, C double bond O, O, C double bond O, CH3 attacks this. Double bond O gets converted into single bond O minus. By getting this, students, double bond O gets converted into single bond O minus. You get this intermediate here, that is C6H5, C6H5, C, this is O minus, this is the H of this, CH2, C double bond O, yeah, O, C double bond O, CH3. This is what you have obtained, right? So this intermediate undergoes protonation, okay, at the anion oxygen to form hydroxy acid anhydride. Okay, this undergoes protonation, so it abstracts a proton. Just write this molecule, that is you have C6H5, CO minus, you have CH, CH2, C double bond O, O, C double bond O, CH3. Okay, this takes up some proton, okay, from the acid that is formed in this step. It takes up some proton to form this C6H5CH, OH, CH2, C double bond O, O, C double bond O, CH3. So it will give you this molecule, that is hydroxy acid anhydride is what you can call it as. Okay, now next what happens is, you all know that beta hydroxy aldehydes, carbonyl compounds, generally they undergo dehydration. So there is a carbonyl group, beta hydroxy, it undergoes loss of water, OH from here and H from here. So loss of water takes place. C6H5, I'm writing the same molecule, OH, CH, I will write as H, C double bond O, O, C double bond O, CH3. So loss of water takes place. Loss of water takes place. CH, double bond CH, C double bond O, O, C double bond O, CH3. Okay, you get this molecule, right? So look at the step. First step is as usual, a proton is abstracted here. So anion generated attracts this aldehyde. Double bond O gets converted to single bond O minus. Okay, as usual in aldol condensation, whatever happens, right? It abstracts a proton, then loss of water takes place. Now, in the last step or the fifth step, what happens is, this unsaturated mixed anhydride finally yields cinnamic acid by undergoing hydrolysis. This molecule undergoes hydrolysis, that is C6H5, CH, double bond CH, C double bond O, O, C double bond O, CH3. Okay, this is the molecule. It is finally undergoes hydrolysis. So water molecule attacks here, the bond breaks. Okay, that means addition of H and OH takes place generally. Water attacks here. So this molecule, the bond breaks. So O minus gets converted into OH. So you get this molecule, that is C6H5, CH, double bond CH, C double bond O, OH. This is what you get. Plus CH3, COOH. So this yields the cinnamic acid. So the reaction takes place in 5 steps here. So as usual, right, if there is an alpha hydrogen, acidic hydrogen, generally a base abstracts it, then it attacks the aldehyde molecule, and then abstraction of proton, everything takes place, then loss of water resulting in the formation of alpha beta unsaturated systems. Then in this what happens is it undergoes hydrolysis to give you the cinnamic acid. Okay, so this is the two important reactions. One is the Perkins reaction, other one is the Claisen-Schmidt reaction, right? So total we have covered 5 reactions. Still 2 reactions are remaining. Another reaction is remaining, that is managed reaction is remaining. Okay, that will deal in the next session. Thank you.